Morning, Internet. It's Thursday. It's 8 o'clock, and I've been up since 5:30. So I'm gonna go get some breakfast. I'm walking to class.
The x direction and a y component, BPY. So far, so good. Notice that BPY is smaller than the initial y. Is that cool? So whenever we talk about, and I'm just going to do it on the side here, whenever we talk about the initial velocity, this guy is v naught y, and the final velocity, vpy, the after vector is smaller than the first vector. Notice that the acceleration is defined to be, at least in the y direction, is delta vy divided by delta t, or a discrete time interval. This then is v final y minus v initial y divided by delta t. So far, so good. If I'm subtracting these two vectors, graphically you're really saying, okay, what do I have to do to the first vector to make it look like the second vector? Well, in order to make this vector look like this vector, I have to have reduced its size. This is then vpy minus v initial y, written as a vector. And you're saying that the direction of this is the same as these guys' direction. That's basically telling you that the acceleration is parallel to the change in the velocity in that direction. So far, so good? I hate doing all this marginal stuff here, but hopefully we got room to do this. Is everyone okay with why the acceleration is vertically downward based on this velocity argument? Hopefully so. The reason I'm asking is because what is happening over here? If I compare point Q and point S, wouldn't we be making the same kind of argument? Sure. Well, let's just sketch them. The vertical velocity for point Q looks like this. This is the velocity at point Q in the y direction. This is the initial velocity. The velocity at point S is larger in the y direction. So velocity at point S in the y direction. So far, so good? Using the same strategy, the acceleration is the same direction as the change in the velocity. That answers the question, what do you have to do to the first vector? This one. To make it look like the second vector, this one, well, you have to make it longer, right? And do you see that this is the acceleration vector? So the acceleration is downwards throughout the trajectory is really what I'm trying to convince you of. So is the acceleration minus g in the y hat direction on the way up? Absolutely. But it's also minus g in the y hat direction on the way down. Another way to say that is it never changes throughout the trajectory. What's the acceleration at the apex? It's still the same as it always was. It never changes. So hopefully this is not overkill. But I think you can also see I'm trying to give you a different set of reasoning, because if you didn't get it from my discussion earlier, I'm trying to give you a different tool. Is that cool? Mm-hmm. Are we all okay? Further questions?
It is Friday, around noonish. I'm actually on a lunch break. Yeah, Thursday. It didn't end great. So, if you're wondering why there's 3 minutes of physics lecture and nothing else, there's not, because I made this to make something else so that this video wasn't completely educational. Because no one wants to watch something educational unless it's really funny. Like the Magic School Bus. I missed that show. Okay, what was I saying? Thursday night, kind of around 4, started in a funk, and it didn't end well. But it's Friday, it's a new day, so far so good. Saturday, looking forward to it, it's gonna be awesome. And I will see you in a few seconds, because I will start filming again in a few seconds.